let's keep going for solving trig functions. Now, this one has the same trig function. They're both cosine. However, they have a different argument inside the cosine. This one has a 2x, this one has a regular x. Same as when they were different trig functions, we don't like when the arguments are different. So what we're going to do is, same as last video, use a trig identity on this one to change them to both just be x. So we have a couple different options if I want to change cosine of 2x using my trig identities. Cosine of 2x actually has 3 trig identities. However, remember, I want everything to be the same trig function. So there's only one trig identity for cosine of 2x that only uses cosine. So then everything is the same function. And that is 2 cosine squared of x minus 1. So that's what I changed cosine of 2x to using my trig identities. Now they're all the same inside, just x, and they're the same trig function. They're both cosine. And I notice, hey, I got a quadratic here. So that means bring everything to one side and factor. So same thing as last video. I would like you to pause the video at this point and try to bring everything to one side and factor it on your own. Remember to use U substitution if you need to. So once you have it all factored, come back and check your work. Let's check your work. So I brought everything to one side to get 2 cosine squared of x minus 3 cosine of x plus 1. I changed that to 2u squared minus 3u plus 1. This is my harder version of factoring because I have a number out in front. So I do first times last to get me 2. And then I need 2 numbers that multiply to this number and add to the middle number. That's negative 1 and negative 2. So I exchanged the middle number for a negative 1u and a negative 2u. Look at what these two have in common, which is a u. And look at what these two have in common, which is a negative 1. Take those out and factor it as 2u minus 1 and u minus 1. Then, now that it's all factored, I change the u's back to cosines. So I get 2 cosine of x minus 1 and cosine of x minus 1. Now that we have it all factored, you can set each of them individually equal to 0 and solve. Once again, I want you to pause the video and try this part on your own. I will tell you right now, both equations are unit circle equations this time, so you should be able to use the unit circle to solve both of them. So try that part on your own and then come back to check your work. Let's check your work. I set this factor equal to 0, solved it, and I got arc cosine of 1/2. So what radians on the unit circle give me a cosine value of 1/2? Well, that's these two triangles right there. They both have an x value or a cosine value of 1/2, so that gives me pi thirds and 5 pi thirds. Then when I solve the other one, I got arc cosine of 1. So where on the unit circle is the cosine value 1? Well, that only happens over here at 0. Also happens to be 2 pi, but we don't count 2 pi. That's not in our domain restriction, so we just have 0. So those are my answers for example 3. Let's look at example 4. Now, this one, don't worry about using a trig identity because it gives it to you. So your first step is we have a 3x and a regular x. We're going to change this cosine of 3x into this. So substitute this in for cosine of 3x, bring everything to one side, and see if you can factor this one on your own. Pause the video, try that out, and then come back to check your factoring. Let's see how you did. So I changed cosine of 3x using the trig identity it gave me, 4 cosine cubed of x minus 3 cosine of x. Brought everything to one side and then looked at factoring. I noticed that they both had a 4 cosine of x in common, so I took that out. And what's left is a cosine squared of x minus 4, which I recognized as difference of squares. this is squared, this is squared. So it's going to factor as cosine of x minus 2, cosine of x plus 2, difference of squares. Now that it's all factored, we can set each of them individually equal to 0 and solve. Once again, pause the video, try this out on your own, and then come back to check your work. And I'll tell you right now, one of them is a unit circle, the other two are calculator problems. So try that out and then come back to check and see how you did. Let's see how you did. I set for cosine of x equals 0, divided both sides by 4. 0 divided by 4 is still 0. Take arc cosine of both sides, so I get arc cosine of 0. So where on the unit circle is the x value or the cosine value 0? Well, that happens here at pi halves and here at 3 pi halves. Those are the two places where the x value or the cosine value is 0. So I got those two answers. Next, I had cosine of x minus 2 equals 0. Solve that to get arc cosine of 2, which, if you try to put this into your calculator, is going to give you an error. That's because it's not in the arc cosine domain. Excuse me. Remember, the arc cosine domain is from -1 to 1. So, same thing happens here when I take cosine of x plus 2 equals 0 and solve, and I get arc cosine of -2. -2 is also not in the arc cosine domain, so that one doesn't work either, which means these are our only two answers. So that gives you a couple examples of what to do when the number inside the argument is different. So we had 2x's in x and we had 3x's in x. Anytime that happens, you want to use trig identities so that the insides are the same and so that you're using the same trig function. Then you can usually bring everything to one side, factor, and solve them individually. So that's it for this video. We have one last video, and in this video we're going to talk about what to do when we have different trig functions and we have different arguments inside. I'll see you there.